Hey guys, we're gonna do partial fraction decomposition. So let's look at this example right here. So the idea is that we're going to take a fraction that looks like this, and we're gonna turn it into split fractions. Okay, so how would I multiply, how would I turn these two fractions, so add two fractions or subtract two fractions until I get one fraction? Well, I would go ahead and multiply the top by, I need a common denominator. So x plus 2 and the bottom by x plus 2. And then here x plus x minus 3 times x minus 3. Okay, so we get 2 times x plus 2 minus 1 times x minus 3. I now have a common denominator, so all over x minus 3 times x plus 2. Go ahead and multiply these out, giving us 2x plus 4 minus negative x plus 3 all over x minus 3 times x plus 2. I'm almost there. Let's get add like terms. So we get x plus 7 over x squared minus x minus 6. So now I'm in one fraction. Okay, so what happens if I want to turn my fraction? You know what? This is the wrong way today. Let's go this way. That's much better. Okay. So what happens if I want to start with, say, this thing and turn it back in to this? Okay, so we have the same example down below. So partial fraction decomposition is when we decompose a fraction, so we split it apart into two fractions that we're adding together, two or more. Okay, so what we're going to do is we're first going to factor the denominator. So I could get something like x plus 7 over x minus 3 times x plus 2. You can use the big X there if you want. Okay, so we factor the denominator. Okay, and then what we're going to do is we know we need to split these apart. So if you look at this, when we look at our first example, you can see that we got a common denominator here. And those common denominators, the factors in the common denominators are the denominators of the terms. So what I'm going to do is split this apart. So I'm going to split apart into two fractions. So I get x plus 7 over x minus 3 times x plus 2. Okay, that's what we had, is equal to something plus something. Okay, the something is x minus 3, and my other piece of my denominator is x plus 2. And then we need to figure out what our top values are so that it equals this piece. Okay, so what do we do next? We're going to go ahead and make this a little easier for ourselves. So I'm going to go ahead and get rid of my denominators. So I'm going to multiply by x minus 3 times x plus 2. And you see that these cancel. Okay, so this guy I'm going to multiply by x minus 3 times x plus 2. Just 2 times x minus 3. So those cancel, and we are left with only the numerator. So x plus 7 is equal to a times x plus 2 plus b times x minus 3. That looks pretty good. Okay, I'm going to circle this for later. So x is true for any value of x will make this equation true. So what we're going to try and do is figure out what our a and our b are. So we're going to plug in, substitute values of x that zero out, you can spell out a term. Okay, so first off, I'm going to look at what would I have to plug in for x to zero out this a term. Well, we're going to let x equal -2. So I plug it in. Any place there's an x, I'm going to plug in -2. So -2 plus 7 is equal to a times -2 plus 2 plus b times -2 minus 3. So again, I use that equation to plug in for x. So I get 5 is equal to, that whole thing goes to 0. So I get -5b divided by -5. So b is equal to -1. Okay, saving that for later. Okay, the next one. We're going to go ahead and let x equal, right over here. Let x equal, okay, for this part, what do I need to plug in to zero out that term? I think a 3. Okay. So I get 3 plus 7 is equal to a times 3 plus 2 plus b times 3 minus 3. So that zeros. I get 10 is equal to 5a. So a is equal to 2. Okay, so here's what I know. Now, I go back to this first part. I'm like, therefore, x plus 7 over x minus 3 times x plus 2 is equal to, my a value is 2, so 2, and the denominator under that was x minus 3, okay. And then it's a -1 over x plus 2. So when I multiply this all out, or add those up, I should get that. Okay, so this is my answer. Woohoo! Next one. 1 minus 4x squared minus 9. Okay, so we do factor the bottom. I get 2x minus 3 times 2x plus 3. That looks like a difference of squares. And then I'm going to set those equal to my two split fractions. Okay, I have two values I'm trying to figure out, a and b. So I'm going to go, and they're different, so I'm going to put a and b up there for placeholders. All right, so now get rid of your denominators. Multiply. Okay, so multiply by 2x minus 3 times 2x plus 3. 2x minus 3 times 2x plus 3. Okay, these everything should cancel on the left. On the right, so I get 1 is equal to, on the right, a times, this will cancel with that. So I get 2x plus 3 plus b times, and then I see that that will cancel, so leaving me with just that factor. So 2x minus 3. All right, now we have to do our lets. So what value is going to, for x, do I plug in to cancel this out? I'm going to let x equal -3/2. Yep. Okay, so 1 is equal to a times 2 times -3/2 plus 3 plus b times 2 times -3/2 minus 3. So those cancel. 2 divided by 2 is 1, and then -3 plus 3 is 0. So that whole thing goes to 0. So I get 1 is equal to, let's see, those cancel. Negative 3 minus 3 is negative 6. So b is equal to negative 1, 6. Okay, let's do the other one. Okay, so we're going to let x equal, what do I have to plug in here? Looks like positive 3 halves. So 1 is equal to a times 2 times 3 halves plus 3 plus b times 2 times 3 halves minus 3. I know this goes to 0, so those cancel, giving me 1 is equal to 3 plus 3 is 6a, so a is equal to 1, 6. Okay, so I go back and I look, therefore 1 over 4x squared minus 9, remember that's the original, is equal to, a is 1, 6. I'm going to put the 1 on the top and the 6 on the bottom. We're going to multiply that by 2x minus 3. And then a negative 1 on the top, 6 on the bottom. My denominator is 2x plus 3. And that is that. Okay, last example. This is a long video, sorry. So if we have repeated factors, we have to do a little trickery. So first off, I'm going to go ahead and factor out the bottom here. So I get x times x squared, so GCF, plus 2x plus 1. And then I see that x squared plus 2x plus 1 is a perfect square trinomial. That would be x plus 1 times x plus 1. So I have this repeated factor. So what do I do when I have repeated factors? I have to set up my fractions with increasing powers. So I'm going to go ahead and do that here. So I'm going to split these up. I'm going to have 3 factors, so I need 3 fractions. I'm going to start with the bottom as x, and then the second factor is x plus 1. And if you have a repeated factor, you keep adding a power so that we end up with this, the least common denominator in the bottom. So repeated factors. You form fractions with increasing powers. So that would be like this and like this. Okay. All right, the top, since I have 3 fractions, I do an a, b, and a c. And then we're going to start the same way as we did before. Okay. So I'm going to go ahead and start with multiplying all of these things by x times x plus 1 squared. And then same with over here. X times x plus 1 squared. That cancels out our denominator, giving us 5x squared plus 20x plus 6 is equal to, the x will cancel, giving me a times x plus 1 squared plus b times, well, only one of those, the x didn't cancel, and only one factor cancels. And then I'm going to add my c. My x plus 1 squared will cancel, so just leaving me with a plain x. So let's start by, let x equal negative 1. Why not? That'll cancel out that guy. Okay, so let's plug in negative 1. I get 5 times negative 1 squared plus 20 times negative 1 plus 6 is equal to a times 0 plus, well, that will cancel, so b times 0 plus c times negative 1. Okay, so that goes, that goes. I get 5 minus 20 plus 6, which is negative 9, is equal to negative c. So I get c is equal to 9. I'm going to circle it right now. All right, let's let x equal 0 this time for this. Let's let x equal 0. to cancel out our last term here. Okay, so 5 times 0 squared plus 20 times 0 plus 6 is equal to, let's see, a times 1 squared plus, oh, when I plug in 0 here, that gives me a 0. So b times 0 plus c times 0. Okay, so all those cancel. That cancels, that cancels. You get 6 is equal to a. Ooh, that was nice. Okay, so I have my a is 6 and my c is 9. But how do I solve for my b value now? Okay, so let's go ahead and for any additional terms, you're going to choose any. So to solve for b, we're going to pick any value of x to solve for b. If you have more than one variable to solve for, you have to choose 2 values of x and then make a system. But we don't have to do that this time. So I'm going to choose x is equal to 1 because that seems easy. And then I know from before that a is equal to 6 and c is equal to 9. So this is my little toolbox of stuff. Okay. So now I'm going to use 5 times 1 squared plus 20 times 1 plus 6 is equal to, let's see, a is 6 times 1 plus 1 is 2 squared plus b times 1 times 1 plus 1 is 2 plus c times 1. Oh wait, what is c, guys? C is 9. Okay, so again, we use this equation to plug in, always referring back to that equation. Okay, so I get, let's see, I believe I get 31 is equal to 24 plus 2b plus 9. So when I subtract minus 2 minus 9, I get 2b is equal to negative 2. Let me double check that. Minus 2 minus 9. Yep. Okay. So then divide by 2. I get b is equal to negative 1. Now I have my coefficients, a, b, and c. So I know that a is, therefore, I'm going to leave a little space, 6 over plus, minus 1 over plus 9 over. I don't remember the order. So x was under a, x plus 1, and x plus 1 squared. And then the original equation was 5x squared plus 20x plus 6, expression, excuse me, this is an expression, equals x cubed plus 2x squared plus x. So this is how we break down this fraction.